Alright, let's try solving the integral from 0 to infinity of tan inverse of e to the negative x over x to the 1/3 dx. And this was the hard integral from dailyintegral.com. So first thing that I can recognize is I'm just going to rewrite this so I can analyze it better as the integral from 0 to infinity of x to the negative 1/3 tan inverse of e to the negative x dx. And I can recognize that this is the Mellin transform style integral. So the first thing I want to do is expand the arctangent term. And I'm going to use that tan inverse of z is equal to the summation from n equals 0 to infinity of negative 1 to the n times z to the 2n plus 1 over 2n plus 1 for the absolute value of z is less than or equal to 1. And with z being equal to e to the negative x in this case, I can know that tan inverse of e to the negative x equals the summation from n equals 0 to infinity of negative 1 to the n e to the negative 2n plus 1 x over 2n plus 1. And if I substitute this back into my expression and then interchange the sum in the integral, I get the summation from n equals 0 to infinity of negative 1 to the n over 2n plus 1 times the integral from 0 to infinity of x to the negative 1/3 e to the negative times 2n plus 1 x dx. And now I can use the gamma integral, where the integral from 0 to infinity of x to the s minus 1 e to the negative ax dx is defined as gamma of s over a to the s. And we are at s equals 2/3. So therefore, this integral that I wrote up above must be equal to gamma of 2/3 over 2n plus 1 to the 2/3. And therefore, I have gamma of 2/3 times the summation from n equals 0 to infinity of negative 1 to the n over 2n plus 1, and now to the 5/3. And now recognize that this is the Dirichlet Beta Function, and it says that beta of s is equal to the summation from n equals 0 to infinity of negative 1 to the n over 2n plus 1 to the s. And therefore, I can say that my integral must be equal to gamma of 2/3 times beta of 5/3. And therefore, that right there will be my final answer. Gamma of 2/3 times beta of 5/3.